Non-Euclidean Geometry by Roberto Bonola. Chapter 1. The Attempts to Prove Euclid's Parallel Postulate. Section 7. The Parallel Postulate during the Renaissance and the 17th century. The first versions of the elements made in the 12th and 13th centuries on the Arabian text, and the later ones made at the end of the 15th century and the beginning of the 16th, based on the Greek text, contain hardly any notes on the fifth postulate. Such criticism appears after the year 1550, chiefly under the influence of the commentary of Proclus. To follow this more easily, we give a short sketch of the views taken by the most noteworthy commentators of the 16th and 17th centuries. F. Commandino, 1509 to 1575, adds to the Euclidean definition of parallels, without giving any justification for his step, the idea of equidistance. With regard to the fifth postulate, he gives the view and the demonstration of Proclus. C.S. Clavio, 1537 to 1612, in his Latin translation of Euclid's text, reproduces and criticises the demonstrations of Proclus. Then he brings forward a new demonstration of the Euclidean hypothesis based upon the theorem, the line equidistant from a straight line is a straight line, which he attempts to justify by similar reasoning. His demonstration has many points in common with that of Nasir ad-Din. P.A. Cataldi, 1626, is the first modern mathematician to publish a work devoted exclusively to the theory of parallels. Cataldi starts from the concept of equidistant and non-equidistant straight lines, but to prove the effective existence of equidistant straight lines, he adopts the hypothesis that straight lines which are not equidistant converge in one direction and diverge in the other, chiefly Nasir ad-Din. G. A. Morelli, 1608 to 1679, takes the following axiom, 14, and attempts to justify his assumption. If a straight line, which remains always in the same plane as a second straight line, moves so that one end always touches this line, and during the whole displacement the first remains continually perpendicular to the second, then the other end, as it moves, will describe a straight line. Then he shows that two straight lines, which are perpendicular to a third, are equidistant, and he defines parallels as equidistant straight lines. The theory of parallels follows. Non-Euclidean Geometry, a critical and historical study of its development. This book was written by Roberto Bonola, professor in the University of Pavia. It was published by the Open Court Publishing Company, Chicago, 1912, and is now in the public domain. Read by Jim Renholt, with programming and illustrations by Jim Renholt, 2019. Thank you for listening.